Welcome to Spaceverse, your portal to cosmic adventures. NASA's James Webb Space Telescope has just begun its mission, and already it has unveiled a universe more enigmatic and awe-inspiring than we ever imagined. The telescope has uncovered signs of a colossal force predating the Big Bang, one that could potentially unravel everything we think we know about our existence. Rather than emerging from nothingness, the universe may have been born from a violent clash with another cosmos. These groundbreaking findings challenge long-held scientific beliefs about the origins of time itself. Could this ancient force still linger, influencing and even threatening the very fabric of our universe? Stay tuned as we explore the startling possibility of another cosmic collision looming on the horizon. What existed before the beginning? For years, scientists have debated what preceded the Big Bang. Some, like the late Stephen Hawking, dismissed the question entirely, suggesting it was meaningless. Hawking famously likened asking about before the Big Bang to asking what lies north of the North Pole, asserting that time and space came into being with the Big Bang itself. However, not all physicists share this view. Scientists like Michio Kaku propose that a deeper explanation may lie in the multiverse, an infinite collection of universes that interact in profound ways. According to theories like string theory, the universe isn't composed of simple particles, but rather of tiny, vibrating strings. In this vast multiverse, collisions, mergers, and splits between universes could generate phenomena like the Big Bang, offering a fascinating glimpse into our cosmic origins. Before we dive in, it's evident that the Big Bang might conceal a reality far more unsettling than we've ever imagined. And this is just the beginning. Evidence for a vast network of interconnected universes traces back to the dawn of time. In the 1920s, astronomers discovered that galaxies are moving away from one another, revealing that the universe is expanding. By rewinding this cosmic expansion, scientists determined that everything originated roughly 13.8 billion years ago. The Big Bang theory describes a singularity, a point of infinite density where all matter, space, and time emerged. But the story doesn't end there. Immediately after the Big Bang, the universe experienced a phase of rapid expansion called cosmic inflation. In an unimaginably brief moment, the universe grew exponentially. Yet the mechanics of this process and the reason it eventually stopped remain mysteries. One possible explanation is the existence of an inflation field, an enigmatic force that powered this rapid expansion. This field might have transitioned from a high-energy, false vacuum state to a lower-energy, true vacuum state, releasing the energy that shaped the universe as we know it. Here's where it gets complex. Quantum fluctuations. Tiny, random shifts in the energy field could mean that inflation didn't halt entirely. Instead, it might have persisted in other regions, spawning new bubble universes in the process. If this theory holds, our universe could be just one bubble within an infinite multiverse, each bubble governed by its own distinct physical laws and properties. The James Webb Space Telescope has recently reignited the ongoing debate about the universe's expansion. By observing stars and galaxies, JWST has provided fresh insights into the rate at which the cosmos is stretching. For decades, scientists have relied on the Hubble constant to measure this expansion, but there's a problem. Different methods yield conflicting results. One approach, based on the cosmic microwave background or the Big Bang's afterglow, estimates the rate at 41 kilometers per second per megaparsec. Another method, using supernovae and variable stars, calculates it at 45 kilometers per second per megaparsec. This inconsistency has puzzled researchers for years. JWST's advanced instruments have confirmed that this discrepancy is real, hinting at something extraordinary at play. Some scientists suggest that this unexpectedly rapid expansion could be influenced by mysterious forces, such as exotic particles or dark energy. However, a groundbreaking study proposes an even more intriguing possibility. Our universe might be merging with others. According to this theory, energy released during cosmic collisions could be driving the accelerated expansion we observe. This isn't mere speculation. The study's calculations align more closely with observed data than traditional models. If this idea is correct, it implies that our universe's history is deeply connected to other universes. The initial inflationary phase may have been sparked by our universe being enveloped by a larger parent universe. Over time, it could have collided with and absorbed smaller offspring universes, shaping the conditions we witness today. This perspective transforms our view of the Big Bang. Rather than a singular event marking the birth of everything, it becomes a localized phenomenon, the point where inflation ceased within our bubble universe. Meanwhile, inflation could still be ongoing elsewhere, continuously giving rise to new universes. If our universe is just one among many, the forces shaping it may be far more complex and mysterious than we currently comprehend. The endless expansion of space. But what does this mean for the ultimate origin of everything? While this theory provides insights into the Big Bang, it doesn't resolve the fundamental question of where the first universe originated. In this sense, the Mother Universe concept shifts the question back rather than answering it entirely. Still, it offers a compelling framework, highlighting a cosmos that is far more dynamic and interconnected than we ever imagined. JWST's discoveries have also reignited discussions about dark matter and dark energy, mysterious components that constitute most of the universe, but remain largely unexplained. Could these phenomena be remnants of cosmic collisions between universes? Some scientists believe so. According to this view, dark energy might be a byproduct of such collisions, driving the accelerated expansion of space. This fresh perspective could reshape our understanding of these enigmatic forces and inspire groundbreaking avenues for research. The implications of this theory are profound. If the multiverse exists, it suggests that anything possible occurs somewhere. There could be universes with entirely different physical laws, where time flows backward or where stars never form. This idea also prompts philosophical questions about our role in the cosmos. Are we just one of countless civilizations scattered across an infinite multiverse? And if so, how does that redefine our understanding of existence? The James Webb Space Telescope is taking us deeper into the universe than ever before, opening a window to test some of the most mind-bending theories about existence. By examining the oldest light in the cosmos, the cosmic microwave background, scientists are on the hunt for hidden clues that could suggest our universe has interacted with others. Imagine this. If two universes collide, they might leave behind a circular imprint on the CMB, like a cosmic fingerprint of an ancient event. While we haven't spotted this evidence yet, the very possibility is thrilling. But the implications go far beyond just scientific curiosity. They challenge the way we think about reality itself. What if the universe isn't a singular, isolated entity, but part of a vast, interconnected web of realities? It's a concept that pushes us to expand our imagination and abandon conventional ideas about how the cosmos operates. Now, here's where it gets really exciting. Understanding these cosmic phenomena could one day lead to technological revolutions. Cracking the secrets of cosmic inflation or universe mergers might unlock forces or energies we never thought possible. These breakthroughs could fundamentally reshape humanity's relationship with the universe and perhaps even how we navigate it. There's also a fascinating twist about time itself. If our universe emerged from interactions with others, does that mean time as we experience it is just a local feature of our bubble? Some physicists believe that in other parts of the multiverse, time could flow differently, or might not exist at all. Imagine a reality where causation as we know it is flipped on its head. Exploring these ideas isn't just about tracing our cosmic roots. It's about rethinking everything we know about reality. The ancient light of the CMB is a treasure trove of information, holding secrets about the universe's infancy and perhaps even evidence of its connection to other realms. Every tiny fluctuation in this light is a potential clue waiting to be unraveled. Recent research has been hunting for irregularities in the cosmic microwave background, areas where the data deviates from predictions. These anomalies could hint at cosmic collisions with other universes or remnants of mysterious structures predating the Big Bang. Detecting such patterns would be a groundbreaking step toward proving the multiverse theory. But this isn't just about physics. It resonates on a deeply human level. It stirs profound questions about our purpose, identity, and connection. If our universe is just one part of an infinite system, what role do we play in the grand cosmic tapestry? Are we a unique phenomenon, or is life thriving in countless forms across the multiverse? While definitive answers may be far off, the search itself reflects humanity's unrelenting curiosity and drive to explore. With the James Webb Space Telescope, we're rewriting the story of the cosmos. Its unparalleled ability to peer at the faintest, most distant objects helps scientists reconstruct the events of billions of years past. Piece by piece, this cosmic puzzle may reveal whether the Big Bang was a one-time explosion or part of an eternal cycle of creation and destruction. The journey ahead is full of challenges, but every discovery brings us closer to grasping the true nature of existence. Along the way, we've uncovered hidden forces, like dark matter and dark energy, that hold galaxies together or drive them apart, hinting at deeper truths about our universe. Yet for all we've learned, so many questions remain unanswered. The universe is staggeringly vast, a boundless playground of mysteries that stretches beyond what we can see or measure. For all the knowledge we've gained about stars, galaxies, and planets, the most profound questions about our existence remain tantalizingly out of reach. But the thrill of seeking those answers is what makes our exploration of the cosmos so extraordinary. What are the unseen forces shaping our universe? What's driving galaxies apart and accelerating cosmic expansion? Let's unravel some of the most perplexing mysteries, from invisible matter to the mind-bending physics that could redefine everything we know. Take dark matter, for instance. It's the mysterious substance making up most of the universe's mass, yet we can't see, touch, or directly interact with it. Dark matter doesn't emit or absorb light, but exerts a gravitational pull that holds galaxies together. Without it, galaxies wouldn't exist as we know them. Scientists suspect it might be made of particles like WIMPs or actions, but no one's cracked the case yet. Solving this puzzle is critical to understanding the universe's structure. If dark matter is the glue keeping galaxies intact, dark energy is the force tearing the cosmos apart. Accounting for nearly 70% of the universe, this enigmatic force drives its ever-accelerating expansion, as if the universe is running away from itself. Is it a built-in property of space, or something entirely unknown? Either way, uncovering the truth about dark energy could revolutionize our understanding of the cosmos. And then there are black holes, the universe's ultimate enigmas. These dense regions trap everything nearby, even light, with their immense gravity. But what lies at their core? Scientists call it a singularity, a point of infinite density, yet this idea clashes with the laws of physics. Adding to the mystery is the information paradox. Does anything that falls into a black hole vanish forever, or is it preserved in some bizarre way? Solving these riddles could transform our grasp of reality itself. The universe is full of questions waiting to be answered, and each discovery reshapes our understanding of the cosmic dance that binds everything together. Galaxies come in a stunning variety of shapes and sizes, from the elegant spirals of the Milky Way to chaotic clusters of stars. But how did they evolve into these forms? The answer lies in a complex interplay of dark matter, star formation, and gas dynamics, though the exact recipe remains a mystery. Then there are galaxy collisions, which are like cosmic car crashes that can ignite bursts of star formation or even merge entire galaxies into one. Understanding these interactions helps us piece together how the universe grew into its current state. Magnetic fields are another fascinating ingredient in the cosmic story. Found everywhere from stars to entire galaxies, these fields likely began as tiny sparks after the Big Bang, growing stronger over time through processes like star explosions and spinning plasma. While their origins are still debated, their influence on galaxy evolution and star formation is undeniable. Solving this mystery could unlock a crucial piece of the universe's puzzle. Massive stars, when they reach the end of their lives, explode in spectacular fashion, leaving behind neutron stars. Tiny but incredibly dense remnants. Imagine packing the mass of a star into an object only a few miles wide. These stars are so extreme that their internal conditions can't be replicated in a lab. Scientists study pulsars, neutron stars that emit beams of light as they spin, to better understand the strange physics at play, but each discovery seems to raise even more questions. Then there are gamma-ray bursts, some of the most energetic events in the universe. These short flashes of energy can outshine entire galaxies in just seconds and are thought to result from dying stars or neutron star collisions. Yet their sheer power and origins remain mysterious. Each burst is like a time capsule, offering clues about the universe's distant past and the life cycles of ancient stars. The cosmic microwave background radiation acts as an ancient snapshot of the universe, taken just a few 100,000 years after the Big Bang. It shows the cosmos in its infancy, but some unexpected quirks, like unusual temperature patterns, hint at physics beyond what we currently understand. And then there's the matter-antimatter puzzle. At the universe's birth, equal amounts of matter and antimatter should have been created, but they annihilate each other on contact. So why does matter dominate the universe today? Something must have tipped the scales early on, but what that was remains one of the universe's biggest unsolved mysteries. What if our universe is just one of many? Some scientists propose a multiverse, where other universes with different physical laws exist. This could explain why our universe seems perfectly fine-tuned for life, though it's impossible to test for now. Time might not be fundamental. Some theories suggest it emerges from deeper physics, raising questions about how we experience reality. The Fermi paradox asks why, with billions of planets, we haven't found life elsewhere. Some believe advanced civilizations avoid contact, while others think life is rarer than expected. Physics still lacks a unified theory to reconcile general relativity, gravity, and quantum mechanics, particularly in extreme conditions like black holes. A theory of everything could unlock answers to the universe's deepest questions. Cosmic rays, high-energy particles traveling at near light speed, crash into Earth's atmosphere, providing insights into extreme physics. Meanwhile, interstellar gas and dust are crucial to star and planet formation, though their chaotic interactions with gravity and radiation are complex. Neutrinos, tiny particles produced in nuclear reactions, help scientists study extreme environments like the Sun or exploding stars. Finally, the universe's rapid inflation after the Big Bang remains a mystery. What caused it, and how did it end? Galaxies aren't scattered randomly. They form clusters, superclusters, and vast filaments connected by dark matter. These structures are the universe's scaffolding, shaped by gravity and matter interactions. By studying their formation, we can trace the history of the cosmos. Could there be forms of matter we've never encountered? Theories suggest things like quark, gluon plasma, or strange matter, possibly found in extreme environments like neutron stars. Exploring these ideas could expand our understanding of the universe's building blocks. The future of the universe could go in different directions. It might keep growing, shrink, or stay the same size. The answer depends on dark energy and the total amount of matter in the cosmos. Figuring this out will reveal the universe's ultimate fate. We have many questions that challenge what we know, from invisible forces shaping galaxies to the possibility of other universes. Each discovery brings new questions and helps us understand not only the stars and space, but also our place in the grand scheme. Understanding the universe is like solving a giant cosmic puzzle without knowing the final picture. From gravity pulling galaxies together to dark energy pushing them apart, these forces may hold the key to understanding the universe's past and future. And that's it. Thanks for joining us on this cosmic journey through the mysteries of the universe. From dark matter and dark energy to the potential of hidden forces and the ultimate fate of the cosmos, there's still so much to uncover. Don't forget to like, subscribe, and stay tuned for more discoveries right here on Spaceverse.